A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material used. This is an interesting problem that will come up in manufacturing for different things. People who are selling goods, who have to package those goods, often want to find the best way to package those goods that minimizes the materials used. So this is a real world scenario. And in particular, we're told that we need to have a box with a square base and an open top. So we have some sort of a box. And let's see. I'm going to do my best to draw this box. We've got a square base and an open top. So it's got some sort of a height h, and then we can call the width w. And since it's a square base, all of the sides of the width are w. And we want to minimize the amount of material used. So we want to minimize the surface area. I'm actually going to do a little more here. There we go. Kind of draw in the edges that we can't see. And so we want to minimize the surface area. I'm going to call that A for area. And if we think about the area, the base is a square that has length w. So the area of that is going to be w squared. And then plus, we've got 4 sides that are vertical, and each one of them is a rectangle with base w and height h. And so we've got 4 of those sides, and the area of each is w times h, base times height. And there's no top, it's an open top, so we don't have another w squared on the top. So it's just going to be w squared for the base, and then plus 4wh for the 4 vertical sides. That is the area, but that's written in terms of w and h. Remember, we need our function to just be a function of one variable. So we need to eliminate either w or h. And the way that we do that is by using the restriction or the piece of information that we haven't used yet, which is that the volume has to be 32,000 cubic centimeters. So we know the volume has to be 32,000. Well, the volume of a rectangular prism, of a box, is basically the area of the base times the height. The area of the base is w squared, and the height is h. So this is w squared times h. And so we can use this equation to eliminate one of the variables. It's easiest to get h alone. We can do that by dividing both sides by w squared. So that gives us h is 32,000 over w squared. And then we can plug that in for h in the formula for area, in the equation for area. And that gives us a equals w squared plus 4w times h, which we saw was 32,000 over w squared. And we can multiply out those numbers and cancel one of the w's out front and in the bottom. 32,000 times 4 is going to be 128,000. And that'll all be over w, because one of the w's in the denominator cancels with the w out front. So now we have the area written as a function only of the width. And now we can differentiate this. If we want to differentiate area with respect to width, that's going to be 2w plus, remember the derivative of w to the negative first is negative 1w to the negative second. So that's going to give us a negative here. And we'll still keep that 128,000 in there, and that'll all be over w squared. Now, it would be nice to combine these into one fraction. If we do that, that will give us 2w cubed minus 128,000 all over w squared. We can factor a 2 out of that. That gives us 2 times w cubed minus 64,000 all over w squared. And this is actually something that we can factor. This is a difference of cubes, and there is a formula for factoring the difference of cubes. If we have f cubed minus l cubed, that factors into f minus l times f squared plus fl plus l squared. This is something that used to get taught in intermediate algebra, but at least when I'm recording this video, we no longer offer that class, and I don't always get to it when I teach other algebra classes. So this might not be something you've ever seen. So surprise, you learned a new formula today. There are other ways of factoring that. You could actually go through and use synthetic division to figure out that 40 is a root and go through and blah, blah, blah. Anyways, that's neither here nor there. This in parentheses becomes w minus 40 times w squared plus 40w plus 1600, which is 40 squared, all over w squared. And so if we are looking for critical numbers, one of them is w equals 0, because that gives us a denominator equal to 0. So this is undefined. We also get one w equals 40 from that factor. And then this factor on the right-hand side doesn't actually have any real roots, any real zeros. This is always positive. So we know that our critical numbers are going to be 0 and 40. But of course, 0 doesn't make sense as an actual answer. These are all dimensions in a three-dimensional object. They all have to be positive, so we can throw away 0. 40 is going to be our actual answer here. We can make a sign chart if we want. 0 and 40. Our factors are 2, w minus 40, w squared plus 40w plus 1600, and the denominator as w squared. 2 is always positive. W minus 40 is going to be negative and then positive. I mentioned earlier that this is always positive and w squared is always positive. So our derivative is going to be negative and then positive, which means the function is decreasing and then increasing. So we have a minimum at 40. W equals 40, so that is going to be our minimum. But we wanted to find the dimensions, so we don't just need W, we also need H, but we have this relationship between W and H right here. So if we plug in 40 for W, that's going to be 32,000 over 40 squared equals H. So that's 32,000 over 1600 is H. And if we divide those out, we're going to end up getting 20. And these are all measured in centimeters. So we have a width equal to 40 centimeters and a height equal to 20 centimeters. And those are the dimensions that are going to give the least amount of material used, giving us a volume of 32,000 cubic centimeters.